Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Four Ring Circus by Nebuzaradan. I hope I said that right. Anyways, here are the rules. We have normal Sudoku rules applied, which means in every cell in the grid, place a single digit from 1 through 9 such that every row, column, and designated 9-cell region, which is a box in this case, contains the digits 1 through 9 once each. We have counting circles, where a circle contains a circle containing a digit n indicates that that digit appears in exactly n circles. So, for example, if you had, say, a 3, a 3 here, you would have to have 3 threes in total in circles in the grid. So you could have something like this, and this would be valid for the 3s. And that's an example of how counting circles work. We also have German whispered lines, where adjacent digits along a green line differ by at least 5. So, for example, if this were a 3, and this would have to be an 8 or a 9, because those are the only digits which are 5 or more away from 3. And I also like to call the German whisper lines whisper 5 lines, because it seems clearer to me about, and you can extend it to the other types of whisper lines, and it becomes easier to know what those are, essentially, once you hear it. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's count how many circles there are. There are 1, 2, 3, 4, 5, 6 batches of circles. That means that's 24 in total. 6 batches of 2 by 2 areas with those circles. So that's 24. And there are at least 5 digits to add up to that 24. There could be more. 9 is not possible because we are missing a circle in column 5 and in row 7. The interesting thing is, though, that basically we have Fistmaffel's corners here. And Fistmaffel, so that relates to Fistmaffel's ring theory, where basically the digits on the corners of the puzzle must be exactly the same as the corners surrounding the central box. So these circles are all in the 2 by 2 areas. The 2 by 2 areas of the 2 by 2 corners of the Sudoku puzzle must be the exact same digits as the digits in the middle. So, the digits surrounding the middle box in the grid. So these 16 digits basically are exactly the same as the digits in the circle. That's interesting. So that means 4 digits. Huh. That means oh, no, it does not mean 4 digits have the exact same. It means up to 4 digits can be in there. 2 are definitely on the Whisper 5 line. They could be the same 2 or different ones. So you have 4 that are the same, so it's at least 5, obviously. You cannot have a 9. If you have 5 digits, then Hmm. Could be a lot of things. What we do have is 21 digits total that are in circles, which are essentially around the Fistimefel ring. Uh, hmm. What does that mean? Hmm. Well, if it's 5 digits exactly, that means these digits must be similar to digits on this line. Hmm. The digits not in circles always obviously can't be in the corner, but they also cannot be on the Fistimefel ring. So they're always going to be here. Um, where is it possible to have an 8? I guess you could have 8, 8 here, potentially, right? So 8 and 8. If you don't have an 8, um, you could still have 5 digits. Hmm. Hmm. Could you have two unique digits that are high? I think, well, yeah, you could, right? Because you could have 2, 4, 5, 6, 7, right? Let's color the Whisper 5 line and see where that leads us. We'll do green and pink here. So then that's green, pink, green, pink, green, pink. And then we'll use orange and yellow. So orange, yellow, orange, yellow, orange, yellow, orange, and yellow. So they're actually this is essentially symmetrical. Uh, hmm. Hmm. Okay, so we add up to 24. We don't have a 9 because one digit's missing in column 5 and one digit's missing in row 7 in a circle. That means 8 is the most you can have. Hmm. This digit has to be 1, 2, 3, or 7, 8, 9, but you obviously cannot have a 9 in the circles because of the missing circles. Same here. 1, 2, 3, 7, 8. Hmm. Hmm. So if you had an 8, where would it have to be? This box is missing a circle. So obviously 8 can't be, 8 has to be somewhere there. So it'd have to be in 8 and 8. One of these two. So this can't be 8, so one of these two and one of these two. I mean, it seems plausible. um, can you have 8 and 7? No. The answer is no. Because we're missing essentially one here, and one here. So that's 6 at most. 8 and 6 at most. So 8 and 7 cannot be in the circles together. 8 and 6, though, could be. 8, 6 is 14. That means the other digits must add up to 10. You could have 1, 2, 3, 4 with that. You could have 2, 3, 5. 1, 4, 5. And those are the only possibilities. Because 6 and 7 are already taken care of. Okay, so adding up to 24, we have 1, 2, 3, 4, 6, and 8. 1, 4, 5, 6, 8. 2, 3, 5, 6, 8. And then 7s. Can you have a 5? Can you have 6 and 7? We probably can, right? No, we definitely can. It's just a matter of... So 6 and 7. Can you have it with 5 and 7? The answer is no. So 6 and 7, because 5 and 7 adds up to 12. And we're assuming no 6. The remaining digits only add up to 10. So 10 plus 12 is 22, and we have 24 circles. So 6 and 7 could work. Doesn't this digit have to be the same as this digit? No, it could be... Yeah, it could be one even, one odd. Um... Hmm. Um... 6 and... So 5 and 7 doesn't work. I think 6 and... So it's either 6 and 8. Wait, can it be 5 and 8? No. Because of the same problem. So I think you're guaranteed to have a 6 then, essentially. Right? Yeah, you're guaranteed to have a 6 because 8, you can't have 7 with it. And if you try to have 5 and 8 as the without 6 or 7, that gives you 1, 2, 3, 4 left. That adds up to 23, and there are 24 circles. So 6 has to be in the circles then. And it's either 6, 8 or 6, 7 as the largest digits. 6, 7 requires the others to add up to 11. So 1, 2, 3, 5, 6, 7 works. And 2, 4, 5, 6, 7 works. Huh. The digits on the fistula filled ring here, so we are guaranteed a 6 in the circles, but we don't know where. We have 7 or 8 in the circles. Um, Nine could be on the Whisper 5 line and cannot be in the circles. So again, the possibilities are 1, 2, 3, 4, 6, 8. 1, 2, 3, 5, 6, 7 for 6 digits. 1, 4, 5, 6, 8. Or 2, 3, 5, 6, 8 for 5 digits. For 5 digits that have a 7, it would only be 2, 4, 5, 6, 7. Oh, that's interesting. This digit is next to 2 unique digits on the Whisper 5 line. So this must be, again, 1, 2, 3, 7, 8. This is next to 2 unique digits on the Whisper 5 line. So again, it's 1, 2, 3, 7, 8. Because again, 9 cannot be in the circles. And the Fistmafel rings are all accounted for in the 2x2 areas in the circle. This could be next to 1 unique digit. So this could be 1 through 4, 6 through 9. Same here, but that doesn't help us much. This one too. This could be 9. It could be 1, 2, or 3 also, right? Because we're not guaranteed. So we're guaranteed 6 and 7 are in the circles. Or 6 or 7 or 6 or 8. Because otherwise we don't add up to 24 without those. Because we can't have 9. So again, it's 1, 2, 3, 4, 6, 8. 1, 2, 3, 5, 6, 7 as 6 digits in circles. Otherwise, it's 1, 2, 3. Oh, that's interesting. It's 1, 4, 5, 6, 8, or 2, 3, 5, 6, 8. And it's 2, 4, 5, 6, 7 as possibilities. Well, anything with 1 with 5 digits would mean the 1 has to be here. Right? Oh, cannot be 1, 4, 5, 1, 4, 5, 6, 8 then. So I think we're guaranteed a 2 in the circles. It can't be 1, 4, 5, 6, 8 because the reasoning is you have the 1 guaranteed in box 3. So the only low possible on the Whisper 5 lines then can only be 4. And 4 has to be next to 9 on a Whisper 5 line. So you cannot have 1, 4, 5, 6, 8 work. What you can have is 1, 2, 3, 4, 6, 8, and 1, 2, 3, 5, 6, 7. So this can never be 4, but it could be 6. So you could have 1, 2, 3, 6, 7, 8 here. And this is also 1, 2, 3, 6, 7, 8. Right, because 4 has to be next to 9. So, okay. Then the possibilities are 1, 2, 3, 4, 6, 8, 1, 2, 3, 5, 6, 7, 2, 3, 5, 6, 8, or 2, 4, 5, 6, 7. Hmm. Okay. Hmm. If it's single digits, 2, can 2, 4, 5, 6, 7 actually work? No. Because if you have 2, 4, 5, 6, 7, one of them is going to have to be here. And then you have the same problem of only one of these can be 2. That means 4 has to be on one of these to be low, but there's no other low. There's 4 cannot be next to 9 on this Whisper 5 line in the circle, which it would have to be. So that eliminates 2, 4, 5, 7, 8 then. So the only possibilities now are 1, 2, 3, 4, 6, 8, 1, 2, 3, 5, 6, 7, and 2, 3, 5, 6, 8, which does work though. Hmm. So 2, 3, 5, 6, 8 works. Because then you could have 3 being next to 8 and 9, or 8 being next to 3 and 1, or something like that. Mm. Hmm. Okay, so we're guaranteed. So then we're guaranteed 2, 3, and 6 in the circles, right? Because again, the choices here are 1, 2, 3, 4, 6, 8, 1, 2, 3, 5, 6, 7, and 2, 3, 5, 6, 8. Hmm. Oh, so, well, no, 4 could be there. Hmm. So, in row 3, what are the digits not on Fistimafel's ring? It would have to be the possible 9 would definitely be there. So we're definitely guaranteed 9 in each corner box has to be in one of these two places. Nine in box 5 has to be one of those. Oh, this could be 9. So that could be, yeah, this could be 9. Because, no, it's Fistimafel's ring, right? That's why it can't be 9. Okay. So 9's not here. 9 has to be one of these. 9 has to be one of these. 9 has to be one of these. That doesn't tell us much. And 9 has to be one of these. Okay. So we are guaranteed 2 2s, 3 3s in circles, a 6 6s, and a 7 or an 8 in the circles. Hmm. So if it's 8, oh, that's interesting. So if it's 8, That means 8 has to be here and here, definitely. That means this cannot be 8. But we know we can't have 7 on this line, in this cell here. Because 7 cannot be in all the circles, because we only have 6 at most in every box left. And this can't be 8. So then this can't be 7 either. Which means this is low. Huh. Fascinating. What happens with 7? Say, can we ever have not 7 not be here? I guess. So say we did not have a 7 here. 7 could be... I think then this always has to be... One of these always has to at least be low. But the thing is... Right, 1, 2, 3, 4, 5, 6, 7, and 8. You're guaranteed to be, yeah, one of these, so... This one, I think... Well, not necessarily. Okay, say this was 7 here. Right, so this is 7. Then this would be 1 and 2. 1 and 2. That would have to be 7 here. So this would be 1, 2, 1, 2. Then that eliminates 7 from here. 7 has to be one of these 2 digits. 7 is one of those 2 digits. This cannot be 7 either, then. Because one of these 2 digits has to be 7. So that can't be 7. And 7's one of those. 7's one of these. So this has to be a low. I guess the question is... Can this be 7? So this can never be 8. Because if this is 8, that means 8 is on Fistmeffel's ring, which means 8's in a circle. So this can never be 8 here. Can we have 7 here? Then that would force this to be 1, 2, 1, 2. This would be 7. This would be 1 or 2. Therefore, 7 could not be here. 7 cannot be here. I mean, technically, this still could be... No, 7 cannot be here, so therefore 7... Right, 7 could not be here or here. It's missing, then, in... 7 is not in a circle in box 2. It's not in a circle in box 8. So then it must be in a circle in box 5, so that's 7. So that's possible. Which means 7 cannot be here or here anymore. Can't be here. It has to be one of these 2. It has to be one of those 2. It has to be one of those 2. So it's one of those 3. So then this would be low. This would not be... This could be 6 or 7 then here. Possible. And then this would have to be 1 or 2. So this would have to be 6 or 7. And it seems feasible. No. Yeah, 7 could not be one of these two. So we have 1, 2, 3, 4, 5, 6. Oh, no, 7 can't be here either. Right? Because the 7 is missing, not in a circle in column 5, but then it also cannot be in a circle in column 7 too, when that's with that being 7. So they both have to be low. So we know then yellow is low. And orange is red. Pink has to be low. And green is high. So this is 6, 7, 8, and this is 1, 2, 3. That's 1, 2, 3, 1, 2, 3, 1, 2, 3, 6, 7, or 8. Okay. We are guaranteed a 6 sixes in circles. We don't know where the 7 is, though. So this has to be 6, 7, or 8 also. This is 6, 7, or 8 because it matches a circle in the corners, which is a circle. This has to be 6 through 9. 6 through 9, 1, 2, or 3, 1, 2, or 3. 6 through 9, 1, 2, or 3, 6 through 9, 1, 2, or 3. This could be 4. Okay. Interesting. Well, Can these be the same? Okay, so one thing we know is they cannot be the same high digit here, right? If this is 8 and 8, we are guaranteed 2 8s that are outside circles on Fistomaphil, in the Fistomaphil ring. If this is 7 and 7, same thing, we're guaranteed 2 outside the circle, or the Fistomaphil ring, outside circles in the Fistomaphil ring, and then another one here. So one of these is guaranteed to be at least a 6. Can it be both 6s is the question. So say we had, well, first of all, if that's 6 and that's 6, then this is 1 and 1 and 1. Ah, not possible. So if this is both 6s, that would mean you have 1 in the Fistomaphil ring here, 1 in the Fistomaphil ring here, and 1 in the Fistomaphil, sorry, 1 in the Fistomaphil ring here, 1 in the Fistomaphil ring here, which means there's 2 1s in circles, which is not allowed. So one of these is 6, which means we are guaranteed a 1. So it's either 1, 2, 3, 4, 6, 8, or 1, 2, 3, 5, 6, 7. We are guaranteed that. So we have 1, 2, and 3, and 6 in circles. That means the other one has to be 2 or 3, but we don't know. So one of these is guaranteed to be 1 because, again, you can't have 2 7s here because then you would have 3 7s outside circles in box 8 and then box 4 and box 6. You can't have 2 8s here because the same problem. You'd have, again, 3 8s outside of circles when it's supposed to be all 8s in circles. Or 8 8s in circles. And again, you can't have 7 and 8 together because of just the way that the circles are work out. So you're guaranteed a 6, which means you're guaranteed a 1, which means it has to be 1, 2, 3, 4, 6, 8, or 1, 2, 3, 5, 6, 7. Okay. So one of these is going to be 6, 1, and 1. 6, 1, and 1. Uh there's also going to be only at most 1, 1 here. So that means 6 can only be in one of these twice, which means one of these two has to at least be 7 or 8. They both could be, right? Um, Interesting. So one of these is guaranteed to be a 6. It cannot be 8. It cannot be 1, 2, 3, 4, 6, 8. Because if it's 1, 2, 3, 4, 6, 8, we're guaranteed a 6 in one of these spots, but the 8 has to be also be in one of these spots. And we have an 8 already outside the puzzle, or outside a circle, in box 8. And then there would be another one here. So it has to be 6, 7. So this is 6, 7 then. It's 1, 2, 3, 5, 6, 7 in the circles. So this is 1, 2, 3, 5, 6, 7. Obviously, this can't be. This is 6 or 7. This is 1, 2, or 3 cannot be here then. Because 3 cannot be next to 6 or 7 only on a Whisper 5 line. So this is 6 or 7, which makes this a 1, 2 pair here. This is also a 1, 2 pair. Interesting. So that means 9 is on the outside, 8 is on the outside, 4 is on the outside. And then we don't know what the remaining ones are. Remaining digit, really. Okay, so this is 4, 8, and 9. 4, 8, and 9. Let's just do Fistum of Bell Rings then. Okay. So these are 1, 2, 3, 5, 6, 7. You have 1 or 2 here, 1 or 2 here. That means either this is 7. Oh, we have a 1, 2, 1, 2 pair in column 2 and column 8. That eliminates 1 and 2 from the rest of the column. Same here, same here. You could have both be 7s. That is possible. One of these, though, is a 6. One of these is a 7. One of these is a 1. The other one's a 2. So, because one of these is 1, the other one's a 2, that means this can't be 1 or 2. Huh. Let's see. One of these is a 6, the other one's a 7. So this cannot be 6 or 7. This can't be 6 or 7. Oh. Okay. Because of that, we know where the 7 has to be in circles? No, we don't. Never mind. Never mind. Actually, we kind of do, don't we? No, not completely. Um, hmm. Actually, we kind of do, right? Again, like this is one of these is 6, one of these is 7. So that eliminates 6 and 7 from those cells here. Um, hmm. We have also one of these is 1, the other one's 2. So that means this can't be 1 or 2 either. I don't know what that helps us with, though. Um, we are guaranteed. So 7 is not in box, in a circle in box. Actually, there we go. Yeah, that's what I was thinking. We are guaranteed 7's not in a circle in box 8. We are guaranteed 7's not in a circle in box 6. So that means 7 has to be in the rest of the boxes. So this must be 7 here. Oops. I don't know what I did. This must be 7 here, which eliminates 7 from here and here. It means 7's one of these two. 7 has to be here in the circle, so this is 7 here, which means this can't be 7. This is 7 here. This 7 eliminates 7 here, so it's 6, which makes this 1 and 1. That 1 eliminates 1 here, so that's 2, which makes this 7. This can no longer be 1 because it's on the Fistamafel ring, so this must be 2. Which means this has to be 7. Oh, we've got a contradiction. That's not good. Hold up. Huh. That's not good. It can't be 2 6s. That's the problem. Oh. Oh no, 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 no. How? Ugh. I'm so close. But this fails. Yeah, and the 6 and 7s definitely both see these cells. So this has to be 7 then, which means neither of these are 7. So this must be... Oh. Okay, what am I missing? I'm missing something. I don't know what. Maybe one of these could be 7? Yeah. Ooh. Yeah, maybe the coloring is incorrect here. One thing we do know is one of these has to be a high, and you can't have two sixes here. So one of them has to be missing. I guess it could be here. Ooh, that could open up the possibility of having 8 again. Oh no. Okay. So the logic behind this might not be correct. Particularly here, actually. I think this logic is correct. I don't think this logic is. Yeah, I think that logic might be incorrect because it's in box 8. Yes, okay. So that might be the problem. Um, hmm. Okay. Let's try to... Yeah, I think this logic was incorrect. So this might not actually be correct. Orange, yellow, orange, yellow, orange, yellow, orange, yellow. I think this one is correct. So again, it cannot be 8 here because that would eliminate all possibilities for this cell. And this cannot be 8, but this could be 7 still. This I don't think can be 7. What happens if it's 7 then? 2, 3, 3. And obviously not 5 on the Whisper 5 lines. So again, if we had 7 here, that would force this to be a 1-2 pair. Well, we don't really care about that, right? What we know is 7 cannot be here. This would have to be 1 or 2. One of these would be 6, so they would be with 1. So this would be 2, that would be 1. This would have to be 7, and that would be 2. Okay, so that seems fine. Yeah, where was I? So 7 could not be here. 7 could not be here. Which means... Yes, and this is the contradiction. 7's already missing in box 2, and it's missing in box 8. No, actually, that's not a contradiction, is it? Either of these could be 7. We have 1 7 here, 7 here. One of these is 6 and 1. I guess this could be 7? No. If this is 7 here, that eliminates all possibilities for 7. And if 7's here, then we're missing 3. So this would have to be... This could not be 6 because it's next to 2 unique digits. So we have 6 and 1. Okay. And 1. So how did I eliminate 7 here? That's what I'm wondering about. This cannot be 1, so this has to be 2, with that being 7. So we have 2 and 7, 2 and 7. 2 cannot appear anymore in the circles, and this can't be 1. So 2 cannot appear anymore in circles then. No 1. No 1 or 2. No 7, a 7, 2. This could be a 1 here. This could... Oh, this has to have a 1 here, which means 1 cannot appear in any of the other digits. This can't be 2. No 2. No 1 or 2. No 7 here, no 7 here, so this is 7. Okay, we have 3, 5, 6. This can't be 1 because we know we have a 1 in one of these cells. So far, this is looking okay. How did I eliminate the 7? That's kind of weird. I uh 7 cannot be either of these, cannot be here, so this is 7 here. Which means neither of these can be 6. This is 8 or 9. How did I eliminate? Anyways. 7's one of these two. 7's one of these two. Cannot be here, so this is 7 here. 7's one of those two. No 6 or 7 here. I don't know how I eliminated the 7. What was my logic there? I don't remember. So far it's looking actually okay. What I think we did prove, though, is 8 can't be... It has to be 1, 2, 3, 5, 6, 7. Right? So we're guaranteed a 6 here. But we cannot have another 6 in one of these two, because that would force a 1 twice in Fistemafel ring, which matches the circles. And therefore 2 1s would be in the circles, which is not allowed. Oh, you could have an 8 be there. No, you cannot have an 8 be there. Because you can't have an 8 be in either of these spots. You can't have an 8 be in either of these spots either. So 8 could work here because that's the only box missing in a circle. But it would eliminate 8 and being in that circle there, which would mean 8 cannot be in a circle in box 2. So therefore 8 does not work ever in either of these two spots. Because there would be 2 8s outside circles in box 8 and box 6 if the 8 was here. If the 8 was here, that would eliminate 8 from being here, which means that in box 2 and box 8, there would be no 8. So this is definitely guaranteed to be 1, 2, 3, 5, 6, 7. Okay, let me clear this again. So we know in the circles it's definitely 1, 2, 3, 5, 6, 7. Because again, one of these is 6, one of these is 8. You cannot have both 6s because then you would have 2 1s around Fistimafel's ring, which means there's 2 1s in the circles, which is not allowed. So it must be one of these is 6 and one of these is 7. Okay, so that's really the question. So we have 6 or 7 here, and it must be with 1 or 2. 6 or 7 here with 1 or 2. So we know that much is true. We don't know where they have to be. Actually, I guess it could be 2 7s. No, it cannot be 2 7s. Maybe. If one of the 7s is here, it could be 2 7s, maybe. Okay, so we're not guaranteed a 6 then. Shoot. Okay. So maybe it's not 1, 2, 3, 5, 6, 7. We're guaranteed a 7. It cannot be 8, though. So it could technically be 2, 4, 5, 6, 7. No, again, it cannot be. Okay, so it still cannot be 2, 4, 5, 6, 7. Because we're guaranteed 1 in 2, 4, 5, 6, 7 here, which would mean 4 would have to be on one of these Whisper 5 lines. And it can't be because it would have to be next to 9. So it is 1, 2, 3, 5, 6, 7. We are guaranteed that. And that's the same on Fistimathel's ring. I can't type. We just don't know which way this is. Okay, so this can't be 6, and this can't be 6, because it's next to 2 unique digits on a Whisper 5 line. So it could be 7 and 7, potentially. No. No, it can't. No. It cannot be. Or maybe it could be. It just can't be 7 here and 7 here. Because then that would guarantee 7 in column 5 has to be in a non-circle, and then we have 3 7s outside the circles. But we showed that it can't be low here, 6 7 here, and then 6 7 here. If this is 7 here, we know the other 7 is outside of a circle here. So this must be a 7 here. So that eliminates 7 here and here, obviously. So 7, this would not be 7. This would be 1 or 2. This could not be 7. So this is how it disproves 7 can be here. But we also disprove 7 can be, if 7's here, right. So that's the contradiction. This is, if this is 7, this can't be 7. The 7 has to be in the circle because it's outside the circle in column 5. And therefore we have 7 7s requiring to be in circles in the rest of the columns. So this must be 7. This can no longer be oh, that's 7. So this has to be 6. I guess this could work. This would have to be 2. This would be 6 and 1. Huh. So far it's looking okay. This has to be 7, that's 2. This can't be 1. It has to be 2 next to the 7. Huh. How did I disprove this had to be 7? We have all the 2s, so there cannot be 2s in circles anymore. Ugh. I need to get all the circles. And remove 2s from them. This can't be 1 or 7. Because this can't be 2, we have a guaranteed 1 here, so none of these could be 1. This can't be 6. These can't be 1. 7 can't be here or here, so this is 7 guaranteed. This can't be 7. These can't be 1. 1 cannot be here. 7 can't be here or here, so this is 7. 1, 2. 1, 2, 3, 4. Wait, yeah, this is... Yes, okay, this does disprove the 7s. Because this 7 eliminates all 7s from being here. This 7 eliminates 7s from being in box 6, and we already have no 7 in box 8. So, we've shown... Okay. From all this cannot be 7 either. So this is definitely low. These are definitely high. These are low. And these are high. So we've definitely shown that. This has to be 6, 7, which is next to 1 or 2. 6, 7 next to 1 or 2. Okay. We showed that if this is the other 6 or 7, which is next to 1 or 2, this cannot be 6 or 7. Right? Which means 7 would have to be here. 7 could not be here, so 7 could not be here, so it would have to be one of these two? We know 7 is already outside in one of these two spots, and it's outside here. So if that's the case, the 7 has to be in all the other circles, does it? Yes, in all the other boxes, the 7 has to be in a circle. So this can't be 6 or 7, which means one of these is 7, which means one of these is 7. So since one of these is 7, this is 6, which makes that a 7. But the problem is, then 7 cannot be in row 6 and cannot be in row 4. So that's a contradiction there. So this cannot be 6 or 7, therefore this must be 1 or 2, which forces this to be a 7, which is next to 1 or 2 here. So then this is high. We've shown that contradiction then. So these are low, and these are high. This 1, 2 pair eliminates 1 and 2 in the rest of the column. So we have 3, 5, 6, 7. We know this 7 eliminates 7 in this column. So the 7 has to appear in all the rest of the columns. Because it cannot be here. That means 7 has to be one of these two. This can't be 7. No 7 here. One of these two must be 7 because we don't have a 7 here. So that means 7 has to be one of these three. This is only 7, which is next to 1 or 2. This has to be 8 or 9. It's next to 2 unique digits on a whisper 5 line. This is 6, 7, 8. This can't be 6. This is 7, 8, 9. This is 6, 7, 8, 9 also. This is 1, 2, or 3 next to 6 through 9 here. So this is 7 here. One of these two is 7. This can't be 7. These can't be 7. So since this is 7, this cannot be 7, so 7 has to be one of these two in column 9, which means this cannot be 7 here, which means this has to be 7. So this can't be 7 here. This 7 eliminates 7 here, so it's 6, which is next to 1 and 1. That must be next to 2. That's 1. This is 2. This 1 eliminates 1 here, so that's 2, which must be next to 7. That means this can't be 7. This can't be 7. This can't be 7. This has to be a 7 left in column 2. That means this cannot be 7 here in column 9, so this is 7 here. And we have 1, 2, 3, 4, 5 7s. One of these is 7. You cannot have 1 or 6 here. No 1 or 2 in column 2. This can't be 1 in row 3. This is 6, which eliminates 6 here. None of these can be 7. This can't be 2. 2 cannot be here. 2 cannot be in the rest of the circles because we have 2 2s already in circles. And 1 has to be one of these 3 in circles here. So that eliminates 1 from the rest of the circles also. So this can't be 1. It's 3, 5, 6. This can't be 1 or 2. No 1. We are guaranteed in one of these boxes the 3, 5, 6, or one of these circles 3, 5, and 6. Now, the remaining digits here are 4, 8, and 9 in column 7. This is a 3, 5, 6 triplet in box 9, which forces this to be a 4, 8, 9 triplet here. This is 3, 5, and 6, which eliminates 3, 5, 6 in the rest of the box. So this is 1 or 2. Where are the rest of 3, 5, and 6 in row 7? It has to be here, because it cannot be here. That leaves these digits as 1, 2, and the other one's 4, 8, 9. This cannot be 1, 2 because of the 1, 2 in the column, so this is 4, 8, 9. That 4, 8, 9 triplet eliminates 4, 8, 9 in the rest of the row, so this is a 1, 2 pair. This is 1, which makes... Oh, we have a contradiction again. Oh, no, this is not 1 or 2. This could be... Cannot be 1 or 2, it's 3 or 4 then. Okay, there we go. This can't be 2. This can't be 7. One of these is 7, so this can't be 7, this can't be 2, it can't be 6. We have a 3, 5, 6 triplet in box 1. This can't be 1, though, so this is 1 here, which makes this 2, which makes that 1. This must be 4, 8, and 9. Remaining digits here are 4, 8, and 9, and 4 is guaranteed to be here, which means this cannot be 4, which means this has to be 4, which means this can't be 4, which means this is guaranteed to be 4, so this can't be 4 here. Okay. We have guaranteed 3, 5, 6 here, guaranteed 1, 3, 5, 6 here. 6 cannot be here or here. Interesting. We have a 3, 5, 6 triplet in row 3. These can't be 7. Where is a 7 in column or row 3? It has to be here, because it can't be here because of 7 in the box, can't be here because 7 in the box. So this must be 2 with 8 or 9. We're not sure which. And this can't be 2 because 2 in the column, so 2 has to be here. This one eliminates 1 here. So where's the 1 in this box 3? It has to be here. Okay. 1 has to be one of these. Okay, so 4, 8, and 9. If this is 4, it would have to have a 9 here. Otherwise, this is low, and it would have to be 3 or 4. Okay. What does that mean? If this is 9, obviously 1 through 4 could be here, but you can't have 1, so it'd be 2, 3, or 4. Can't be 4. It's next to 2 unique digits here. We have a 3, 5, 6 triplet in column 1, which eliminates 3, 5, 6 in the rest of the columns. This can't be 3. This is 4, which must be next to 9. This can't be 4 and 9, so that's 8, which makes this 9, which makes that 4. This 8 eliminates 8 here, so it's 9, which means this cannot be 9 here. This is a 4, 8 pair, which eliminates 4 and 8 in the rest of the column, so this is 9, which means none of these could be 9. So to be next to each other, it has to be 8 and 3. So this is 8 and 3. This must be 8 or 9. This 8 eliminates 8 here, so this is 9, which makes this a 4. 8 and 9 is next to 1, 2, 3, or 4. This cannot be 1. This cannot be 2 or 3, so this is 1 or 4. Okay, we have a 3, 5, 6 triplet again. In this 3 eliminates 3 here. So this is a 5, 6 pair, which eliminates 5 and 6 here. So that's 3, which means none of these could be 3. This 3 eliminates 3 here. So one of these two is a 3 here, which means this can't be 3 either because of the 3. This digit remaining here has to be a 2. This 6 and 7 eliminates 6, 7 here. This cannot be 9. So this has to be 8. Which means this can't be 8 or 9. That's 4. This can't be 4 or 9. That's 8. 4, 8 is here. 4 would have to be next to 9. 8 would have to be next to 2 or 3. This is a 2, 8, 9 triplet in row 8. This is 1, 4 as a pair here. This 3 eliminates 3 here. So one of these two is a 3. This 3 eliminates 3 here. We have a 5, 6, 7 triplet in column 4, which eliminates 5, 6, and 7 in the rest of the column. So we have, what, 2, 4, 8, 9 left? 2, 4, 8, 9. And this can't be 2. This can't be 2 because of 2's in the row. This can't be 8. This can't be 9. If this is high, it cannot be 7 or 9. It would have to be 8. If this is low, it would have to be 2 or 3. It cannot be 2. It'd be 3. So this is 3 or 8. We have a 4, 8 pair in row 2, which eliminates 4 and 8 in the rest of the row. So this has to be 3. 3 is next to only 8 and 9. This can't be 8. So this has to be 9, which makes this 4, which makes that 8. That must be 8 here. This 8 eliminates 8 here, so it's 4. This can't be 4, so it's 9. This can't be 8 or 9, so it's 2, which eliminates 2 here. This 9 eliminates 9 here, so it's 8, which makes this 9. So this could be 1 or 4 still. 3 eliminates 3 here. This becomes a 5, 6 pair, which eliminates 5 and 6 in the rest of the box. So this is 3. This cannot be 3 here. We cannot have a 3 here. Where is the 3 possible then in circles? It has to be 1 here, 2 here, and this must be the third. So this is 3 there. Remaining digits in column 2. We have a 5, 6, 5, 6 pair actually in column 1, so therefore that forces us to be 3, so this can't be 3. Remaining digits here are 3 and 8. Remaining digit here is a 2 in row 1 because of the 3, 5, 6 triplet. This has to be 5 or 6 because it's the only possibilities in row 2. That eliminates 5 and 6 in the rest of the column. So now we're looking at 1, 2, and 4 in column 6. This can't be 2 or 4, so this must be 1, which makes this 4, which makes that 1. That makes this a 2. Okay, we are guaranteed. Where are the 6s? 6 is outside. Is 1 here, 2 here, 3 here. So we need to have 6s in the rest of the boxes. So 6 has to be here. 6 has to be here. Right? 6 can't be here in box 4, cannot be here in box 8, can't be here in box 6. So it must be in the rest of the boxes. So this is 6, which makes this 5, which makes that 5, 2, which makes this 6, 5. This can't be 5. This is a 3, 6 pair. 5 eliminates 5 here, so it's 6, which means this can't be 6. We need a 6 in box 5, so this must be 6 here, which makes this 7, 5, 7. This 6 eliminates 6 here, so it's 5 and 6. This 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so it's 5 and 6. 6 eliminates 6 here, so it's 3 and 6. 8 eliminates 8 here, so it's 9. Remaining digits in column 9 are 1 and 3. This can't be 1 because of 1 in the row, so this is 3, which makes this 1. 3 eliminates 3 here, so it's 8 and 3. We have 4 and 5 remaining here. This can't be 5 because of the 5 in the row. So this is 4 and 5. That leaves this as a 4, this as an 8, and this as a 5. Whew. That was, yeah, pretty crazy break-in. I made that mistake here. This one specifically. I think I correctly identified this could not be 7. But then I established it to here, and that was incorrect. Obviously. Fortunately, it led to contradiction. So I didn't start going down. I didn't come to the conclusion with a bad premise. But, yeah. One of these had to be 6. And therefore, the other digit with it had to be 1. But 1 could only appear once in the circles. So therefore, the other one had to be 7 or 8. We tried to have 8 here, but that would eliminate 8 here, so that was the reasoning for that. Yeah, hopefully you didn't make the same mistake I did, which clarified this correctly and said this could not be 7 or 8, but messed this part up. I think, yeah, I don't know why. Maybe because of the symmetry of the puzzle, I just assumed that this also had to follow, but I forgot that these circles are in different places. So that's not complete symmetry there. I don't know. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.